Hello, this is a proof of concept to show that the Power Platform privilege escalation is not just an insider threat, but also in an assumed breach with an attacker having only user shell on the victim, that it may be possible to get credentials in some manner. I'll show three, but I'll just mention that these are not necessarily things I think Microsoft needs to remediate. This is just an example of getting tokens from a current logged in user. There's also related research down here, and again, just the three options that I'm going to demo here are, one, getting credentials out of Microsoft Teams using procdump or a lulbin that dumps process memory. Typically, you'd expect to see this done on like LSAS or a privilege process, but not a userland like Teams, which they do with Teams filtration. And I'll show in the supporting documentation. So anyway, there are also ways to get credentials out of like PowerApps or the browser, like Microsoft Edge, or any Chromium-based or Electron-based app. So, you can just force close all their instances and reopen them with remote debugging port. Also not new, but just another example of a way to get creds. I access this local session storage to dump refresh tokens and then brute force a valid one to get access tokens. And then we can use that to upload a PowerApp as the user that is potentially logged in to the browser. And then the last way is through Outlook with Comm Hijack. So if they have Outlook open on their machine, we can try to send emails from them and set mail rules to control communication, so they never know that we have access to their account. But we can also try to phish and escalate further. So that's the kind of general idea. So we do have like a user shell, PowerApps, this is the process we're going to use, Teams, this is kind of the process, and Outlook, all the things that I just explained for how to escalate privileges there, or at least get credentials to do actions. And it does require a couple assumptions that obviously the attacker has user shell on the victim. The victim one is going to be the IT intern. So this is just an example of maybe they have a personal device that they're MFA'd into, and that's how we trust their account. It's a fully patched Windows 11, Windows Defender is enabled. So just noting that, remote debugging port and stuff like that is not flagged or anything, at least to the user. So the user eventually opens PowerApps in like a Chromium-based browser or Outlook or Microsoft Teams, just ways to get those credentials from them. So, and then victim 2, not really applicable for assumptions, but you'll see what we can do if they open the PowerApp that we send them as the first user. So that's that. All right, so now I'd like to explain what it's going to look like, because there's a lot of windows and tabs open. So this is just an explanation of what's going on. On the bottom left here, this could be just a terminal, but I have Visual Studio Code open, and this is the terminal we'll be typing into. This is just to simulate the attacker with a user shell on the machine. And then I also just wanted to show the code and all the stuff that's running. So that's why that's there. Then we also have, again, we're simulating that we have user access on a person's machine. So they are actively working. This is Outlook logged in as the IT intern. There's also a Teams desktop app, Outlook and Teams desktop down here, that is also logged in as the IT intern. And then their browser, they also are logged in as the IT intern into PowerApps, and that's how we're going to dump the token out of the Chrome browser, or the Chromium-based browser, Microsoft Edge, and get their credentials there. So other than that, that's what we need for the exploit to work. I do have extra tabs open to keep track of all the things that are happening. So like Teams for this user, Outlook for this user will also open, probably Flow as well for this user. And then just to watch as emails flow, because we're going to demonstrate control over email, this is the inbox up here. And then for the same user, this is the deleted items down here. So we'll see as we create a mail rule that it won't show up in the inbox, but it will go directly to the deleted. And then as we send emails as this person, we'll monitor the inbox of this user over here, which is the global admin. So that's who we'll phish as the account that we've compromised. And then this is where we'll see like their OneDrive and also their email. So that's all the tabs, and we can do the demo. All right, so now I'm going to just show that I'm not running under an elevated prompt. So user as admin is false. Here as admin is just going to do, it's just going to look at the current user and check that they are not an administrator. So other than that, we're going to just execute this, and it's going to happen pretty fast. What you should see is these browser tabs on the right, since we're simulating being logged in as a user, are going to close because we need to close them and reopen them in order to hook to dump the credentials. So we hook the browser using that remote debugging port operating command line argument. I'm sorry. And then now we have access to the session storage. So down here, you'll see that we just dumped the session storage, brute force to valid token, and now we are evaluating our flows. So here are all the workflows and all the connections that we have as this user. So we're now executing commands at the command line that are typically done in the browser. And so these are all the connections, like the users over here. And if we scroll down, we have, it's currently now trying to import and upload the app. So the app does not exist right now. So there's only this app up there, but it's going to import this malicious one over here. It's a zip file. Typically what you do in the browser is import new Canvas app up here and then go from there, but we're not doing that. So the other thing though I did want to mention here, I'm just trying to keep up with the script, is that the shared flows, we see global administrator has a shared teams connector with shared flows. So if we come over here, we'll see shared flows, and the global administrator has this flow here that has the users and the teams connector, and we've shared it with the IT intern, which means that this IT intern can actually come in here and edit this flow if you wanted to hijack it, because what we can do, and you'll see this in the proof of concept, is that because we use this connector here, we can essentially inject an HTTP action. And this is going to be very slow actually. So, but we can do this and then update a mail rule and run as previous runs using this up here, using the credentials of the global admin and potentially take over this flow, and then update down here to get like all the global admin's private teams chats. So that part is going to take a while to demo. So I'm just going to leave that where that is, and this script is continued to run. So we'll refresh Power Apps. We'll see that there's a new app here as of a minute ago. Here we're now dumping all of Microsoft Teams processes to get valid Skype token here to demonstrate control over Teams. And we also looked at Outlook using Comm objects, which you probably heard the ping a while ago. And so what happened was this Outlook we just connected to with Comm objects and sent an email as this IT intern. So now I'm going to just flip back to, again, this is the inbox, and down here is the deleted items. And we'll see that there was a mail rule that was created right here, malicious rule. So this was created from the Comm object hijack as this user from the command line. And they created a mail rule and then sent an email over to the global admin. And the global admin has an email from the IT intern. I just put the URL in the subject to help the mail rules a little bit for now. But essentially, it sent an email, and then it just says, can you please take a look at this? What do you think? And this is a malicious app that it just uploaded from the command line. Again, the attacker never had browser access. So let's just say that this global admin is, a little bit hesitant. So they just reply and they say, hey, I'm a little suspicious. Or no, we'll just say, why? Right? And then we'll say, okay, so they just replied why. And over here, we'll see that it never came to the inbox. It just popped up down here. And now my script just picked it up and it just replied for this IT intern who, again, from their inbox perspective, never received an email from this global admin. And imagine like command and control server, something that we can interact with this a little bit more than just like a script that auto replies. But the idea is, yeah, so it just replied as the IT intern. It's totally cool. We're coworkers, trust. And so this is the app, right? And so now, just to show again the global admin, this is the important part. Create rules, manage rules, no rules as the global admin. Go to OneDrive, refresh, no files. And so now what we're going to do is open this malicious app that this IT intern just made, right? It's called, as of 3 minutes ago, M365 Phish, and we say skip for now. This part may take a while. But while it loads, that's what we're going to do. The other thing that it did is with Teams. So I do have open Teams here as, again, we hijacked this user, IT intern, and Teams is also open on the desktop client. So I have this loop running in the script that is going to set the activity filter for using those tokens. And so here we see it's unread only. And if we uncheck it, it's just every second, it's just going back, because that's what we're doing, is we're looping forever and just auto replying to those Outlook emails and then setting the Teams setting here. And if we go in the browser, you can see it does the same thing. And the idea is, if we can route all their notifications and read them before they see them, and we can basically try to route them here, and they'll never, even if they go to the activity log, they'll never see it, those messages. But even like in chat, we can control, I don't know if I have it in this proof of concept, but we can mute. So if we start in chat instead of email, we can mute the conversations so we never get notifications. We can even hide the chats, and they just kind of like seem to disappear even if you try to search for them. So that's another method. They pop back up if the other person responds back, but again, we're just looping every second. We just hide things. We have control over this user's account, so we can try to get those so that IT intern never sees them. And so this can take a while for the app to be ready. And essentially what's going to happen is this IT intern also create the workflow also has the app also imports this workflow, which you have to enable. And what it's going to do is when this person allows it. Okay, so now remember, on the left-hand side, we have the global admin. And on the right-hand side is what actions are actually going to happen when we click allow. So the global admin thinks, oh, it's just using Office 365 users connector. What could possibly go wrong? It's only used to like pull data from a profile. Well, as soon as I click allow, yeah, so we have now created a mail rule on that account using the HTTP user action. We have also touched that file's OneDrive. And we have access as this user to their OneDrive and all SharePoint sites that they have access to through the Graph API. So it was created with the user's action a few seconds ago. And so if you look at the flow run 32 seconds ago, you'll see that this is as the IT intern that we uploaded this. We are doing placing a file in OneDrive by, actually maybe it's a little bit easier to see, do this. All right, so we right here have a directory traversal using this Office 365 users connector, and we're touching the Graph API to put a file on their OneDrive. And yeah, so that's interesting. Then here we're using the Graph API to manage mail rules on the user's account. So we can do that. And this works across other connectors. I have a whole nother video about it. But what we've also done is we've also done another directory traversal down here where we send an email to ourselves that we get right here. Just demonstrating that this email could be sent for like exfiltration or further phishing, so like sending an email as the global admin to someone else to open the workflow and get access to all of their stuff. And if this workflow also had the Teams connector, we could get access to all of the private chats for whoever opens the app as well. And again, all that's described in the other video, but just to show in the over here, this global admin, sending mail with user action HTTP request. And that's the title right there that we give the content, the body, I mean. So that's the general idea. From a user shell, we hijack this user's account using the applications that they are running on their computer. Again, credentials, the way that we get them doesn't matter. It could have been cache files, could have been anything, intercepting their network traffic, or I don't know. But anyway, so we do that, hijack this user, send it to this other person. They open it. Those actions get run under their account. They, and yeah, that's it. All right, so that all happened very fast in the demo. So I just wanted to walk through the code and just show what it did. So we basically just have a bunch of helper functions. So parse JSON web token does what it does. Parses JSON web token. Dump processes. This is where we pass it some processes to search. In this case, it was Microsoft Teams, and then it dumps all of those processes using proc dump, and this could be hot swapped for another living off the land binary, but you dump them into a dump file where then they are all read later with parse dumps, where we parse all those dump files, and we're looking for a regular expression, which is going to be those token strings that we're looking for. And so that's what parse dumps does. Brute valid tokens, we're going to brute force valid refresh tokens, because when we look for refresh tokens, again, it's just a regular expression, and sometimes with character data it just gets mashed, or not all of it, or whatever it is. So we brute force the string that works for us in order to get a valid token, and then we also get an access token that we pass back. So that's what that does. The scan WebSocket. So this is what happens when we connect through remote debugging port to a Chromium-based browser or an Electron app. So we query that WebSocket for the local storage, and then we parse that local storage for that refresh token that we're looking for. Get valid tokens here is going to be the didn't we just do that? Brute valid. Okay, no. Get valid tokens. This is where we actually are wrapping the scan WebSocket. So these are the parameters to get the session storage as we connect to the Chromium debugging port up here. That's right. And then we run through, and then we get and brute force those valid tokens after we do a select string, which is like a grep in Windows. PowerShell to try to extract those matches, and the pattern I think is also in a config down below. And then this is another helper function to brute force valid Teams tokens. They're a little bit different because the Skype tokens are Skype tokens. So this is the endpoint that we're testing against, just to get back the user profile. If we get it, then it's valid. If not, then it's not. Get Power Platform connectors. This is where we're enumerating all the current connectors, which will help us judge what kind of apps we can upload as that user that we've compromised, and then also see what shared flows that we might be able to take over with database credentials or third-party actions or anything like that. And also, you know, just we can also dump all the current flows too, because sometimes they have API keys and stuff too, and those, like, they're secrets, kind of like GitHub repositories or so, something like that. So that's also possible, just not in this proof of concept. But also, yeah, so getting flows. So we get all the flows, we evaluate the flows, just parsing what data comes back, and putting it in a way that we can present it back. So that's all that does. And then import PowerApp does what it says. It imports this zip file here. Again, could be anything, but we would tailor it based on whatever connectors we have available to us. Ideally, the user's connector, because it's just so unexpected that it would touch your OneDrive and all your SharePoint sites and stuff, but also the Teams connector. Again, with my other video, I show you can connect to and get access to private one-on-one chats. But even DevOps and other connectors are also very nice. And although I haven't tested DevOps, but I believe it should work the same. But yeah, as we move on, all this stuff is just trying to get the file there. You need to import it. You need to upload it, then you need to import it, then you need to update some schema to say that you're going to use existing connections so you don't have to log in again. That's why we need the user to have those connections there. But that once we import it, then we continue through. Eventually you need to enable the flow, because when you import, they are not enabled by default. So if you import a new payload that has multiple flows, you'll probably want to iterate on them rather than what I'm doing here. But in general, we overall, when we're done, we return an object that has the URLs to all of our assets that we just deployed, and then we can use that to send emails and stuff to Phish more. So then now send email just does what it does. So this is the comm objects for Outlook, right? So this is how we send an email. This is how we add a rule. Shouldn't be there. Then invoke respond to deleted emails. So this is when we're looping, we're looking for those emails in the deleted that our mail rule routed all those replies to the deleted, and then we reply to those and then permanently delete those. So that's what we do here. And then this is the main function. So those are all the functions and the helper functions. Now we get into the main. So the first stage is getting that PowerApps token and uploading the malicious zip file. So here we connect to Microsoft Edge, and then we force close it here, force close all instances, and then reopen with these parameters here, which again is not a new thing. It's in the supporting docs that I've linked as well. But the only new thing here, I guess, is that I'm looking at session storage instead of getting cookies. And in session storage, we look for those refresh tokens and trade those for access tokens, and hopefully have somewhat of persistence depending on, like in the browser, I think you'll get 24 hours with a refresh token, and in a native app, you'll get like 30 or 90 days, something like that. So, and then you have Chromium debugging dump options. So, you know, when you open a port and a WebSocket, you're going to have all the tabs. Somebody could have like hundreds of tabs open, and we don't want all those tabs. We only want tabs that have the URL that contains Power Automate or PowerApps. That'll just help limit the amount of stuff that we have to scan through. And this is the pattern we're looking for. This is a regular expression to look for the refresh tokens like that. And then we loop through, and here there's more research on trying to do there's more research on blinking. It's called family refresh tokens. Family refresh tokens. Yes. All right. I don't know if I know enough to cut that out, but here we go. Family refresh tokens. This is an interesting GitHub project that just shows authenticating to multiple services with a valid client ID. So essentially what that means is this client ID can get you access to PowerApps, and this auth token can also be used for flow, but also this client ID can be used to request specific, just scope on flow. So, but this scope works for both PowerApps and flow. These scopes only work for Microsoft Flow. But the refresh tokens or the client IDs are the same for these two, whereas Flow can also use this client ID that I've seen as well. So it's just a little bit of interesting stuff there. So, but anyway, we loop through, get the valid refresh tokens based on all those parameters. Once we found one, we'll loop until they open the browser with PowerApps, and then we get it. And then once we find it, we run through all these actions, which are going to, again, get all those and enumerate all the Power Platform connectors, get the default environment right here, and then upload our PowerApp. And then we get that app URL here, and that's where we set the malicious PowerApp URL, and we're interacting with comm objects now with Outlook. This is stage 2. So now with stage 2, we just send an email that says, hey, to the global admin or whoever we're phishing next, based on our very first parameter here, we are going to, where was I? Send, email right here. So after we send an email to that user, we're also going to add a rule that is going to make it so when this user that we just sent to replies, if they reply, it will be routed directly to trash, and we can try to intercept that as an attacker that has access to this person's account. And then the process strings here, this is stage 3, so here we're going to process the Teams application and dump anything with teams.exe and run through this whole stage of using proc dump to dump possible refresh tokens. So we dump all those processes, we parse the dumps looking for this pattern here, which is the Skype token. As I mentioned, it's a little bit different. We can look at a little bit less things that get returned rather than just looking for EYJ. And then we brute force a valid Teams token, and then we use the valid Teams token along with the comm object manipulation with Outlook in order to run through a loop forever. For every 1 second, we're going to look at Outlook, and then we're going to auto reply to those emails and delete them. And then this is where we set the unread and read back. So that's a little bit of a walkthrough through the script, and